Good afternoon, guys. I hope you guys are doing amazing and having a fun time listening to the sessions at PrestoCon. My name is Pratik Joseph Dabre, and here with me is Pramod Satya, and we both work as software engineers at IBM. And today we are going to talk about connectors in Presto, specifically the TPCDS connector in Presto C++. So before jumping into adding a connector in Presto, let's talk about plugins. One of the most important features of Presto is its modularity and extensibility. And a plugin is a way to add new functionality, like telling Presto how to connect to a new data source, register custom functions, types, and much more. Think of a plugin as an external additional code that hooks into the Presto engine at startup. A connector is also a Presto plugin. In Presto, a connector is essentially a bridge between the query engine and an external system. The architecture is pluggable. Connectors are loaded at runtime using Java SPI. The connector handles the entire lifecycle, from discovering tables, splitting work across nodes, and reading rows into the engine. Users write a plugin class, implement all the necessary interfaces and APIs, register it using a catalog file, and you're good to go. You can use your new connector. So in order to add a new connector in Presto Java, you need a set of interfaces to be implemented. The core of every connector implementation starts with two things. First is the connector factory. A connector factory tells Presto how to create instances of the connector, and you can pass in any config properties through the connector factory through to the connector. And the second thing is a connector class itself, which acts as the main entry point for all communication between the Presto runtime and the data source. The connector factory also needs to implement the connector handler resolver, which maps engine level handles to connector specific implementations. Presto Planner and Execution Engine treat most connector-specific structures as opaque handles, like table handles, column handles, right? So the engine need to know the exact connector-specific class to cast to. That's where the connector handle resolver comes in. From there on, we need to talk more about the connector itself, right? The connector contains the connector metadata interface to handle table, schema, and column level metadata. It also has a connector split manager API, which is used to divide a work for parallel execution. Uh, you also need to implement the connector transaction handle, which represents the connector's transaction in a query. These are some of the interfaces that you need to implement in order to get your connector up and running, but you still have access to more optional interfaces like such as the connector page source provider. And what it helps you to do is it helps you to read data, ingest data into the Presto server using in the Presto page format. Uh, I think that's about it for my end, and I'm gonna pass it over to Pramod to talk more about the TPCDS connector in Presto C++.
Thank you, Pratik. So now that we're familiar with what connectors in Presto are, let us take a look at the TPCDS connector. We'll start with some quick background. What exactly is TPCDS? So TPCDS is a standard benchmark that is provided by the TPC organization, and it is used for evaluating the performance of different query processing engines. So the benchmark, it consists of 7 fact tables and 17 dimension tables. So the fact tables, they contain like core transactional data, such as sales and returns. And the dimension tables, they provide descriptive information about these fact tables, like customers, which provides information about the customers. So the PPCDS benchmark, it uses something called scale factor in order to define the data size of the benchmark database. So the scale factor, it roughly corresponds to the data size in gigabytes. For instance, a scale factor of 1, it corresponds to a raw data of 1 GB. So coming back to the TPCDS connector, so the TPCDS connector in Presto, it's used to generate data for different TPCDS tables at different scale factors. One thing to note is that it does not support writing of this data to an external location. And if you want to write it somewhere externally, you'll need to use CTAS queries with other connectors like Hive and Iceberg. Next slide. Okay. So yeah, before looking at how the TPCDS connector is implemented in Presto C++, let's start with some quick background on what connector protocol is. So in C++, we use something called Presto protocol to convert different Java classes in Presto to their C++ equivalent in a convenient way. So what this means is, as a developer, all you need to do is specify the Java classes that you want to convert in a YAML file. And under the hood, Presto protocol, it uses Mustache, which is a logicless templating language. So what I mean by that is it works by basically expanding tags from a template with values that could be provided by a JSON object. So the JSON, corresponding to these Java classes that you had defined before, it's generated by a Python script. So that is the gist about Presto protocol. So connector protocol, it's a part of Presto protocol, and it provides you methods to serialize and deserialize these different connector classes in Presto to and from JSON. So as we saw before, each Presto connector, it should define an implementation of connector handle resolver. And this handle resolver for a connector, it will provide implementations for different handles that are used by the connector, like connector table handle, column handle, and so on. So the connector protocol in Presto C++, it provides a convenient template for you to serialize and deserialize these different classes from the connector's handle resolver to and from JSON. So these connector protocols for different connectors, they're maintained in a registry so that you can just look it up using the connector's name. And it is added to this registry by Presto to Velox connector, which we'll now take a look at. So Presto to Velox connector, it's basically a helper class in Presto C++, which defines the logic to convert different connector handles and connector splits from Presto to their Velox equivalent representation. So the Presto to Velox connector for all of the different connectors that are supported in Presto C++, they're maintained in a registry, as we saw before with connector protocol, so that you can easily retrieve it using the connector's name. And the Presto to Velox connector, it provides APIs that are used while converting a Presto plan fragment to its equivalent Velox plan. So for example, when you're converting a table write plan node from Presto to Velox, or you'll use the API to Velox insert table handle to convert the Presto create handle to its equivalent Velox representation, which is connector insert table handle. So the Presto to Velox connector, it also provides the API to Velox split, which is pretty important, and it's used to convert the connector splits from the Presto tasks to the corresponding Velox connector split representation. So the Velox connector split, it will be processed by the table scan operator in Velox, which gets data from Velox connectors. So now that we have this background, let us now take a look at the TPCDS connector implementation in Velox. So connectors in Velox, they're similar to connectors in Presto, and they allow users to read and write data, from and to external locations. So the connectors, they're used by the table scan operator in order to read data, which is typically from an external source. And they're also used by the table write operator in order to write data to an external location. In Velox, you have a connector factory similar to Presto, which lets developers create instances of a connector. And these connector factories are maintained in a registry and mapped to the connector names. So the connectors in Velox, they should provide implementations for two APIs, or create data source and create data sink. So the create data source API, it's used to obtain a connector data source instance. So a connected data source, it's like a source of data, and it basically implements two APIs, add, split, and next. So what these APIs do is, with the add split API, you can consume a connector split, And then you can call the next API from data source repeatedly on the split to process the split and get a batch of output rows. And you can do this until all the rows in the split are processed. So create data sync. Similarly, it's used to obtain a connector data sync, and this will allow a connector to write Velox data vectors to an external location. As we saw before, the TPCDS connector, it only supports generation of data in Presto and doesn't let you write data to an external location. In Velox as well, will only provide an implementation of data source, and this will be the TPCDS data source, and there won't be any data sync. Okay, yeah, before looking at how the TPCDS data source will process splits and generate data, let's start with some quick background on how exactly the TPCDS benchmark supports generation of data. So the TPC org, along with the TPCDS benchmark, it provides a tool called dsdgen, which allows you to generate data for the different tables defined in the TPCDS benchmark at different scale factors. So dsdgen is a C program, which is part of the TPCDS specification, and it's recommended to be used by the TPC organization in order to ensure that your database contents are exactly as per the specifications. But as we know, Velox is a C++ project, and these dsdgen source files, they're written in C. So we borrow the dsdgen source files, which are written in C++ from DuckDB's TPCDS extension. So dsdgen also supports generating data in parallel using these two options that you need to configure, parallel and child. And in order to use this support, we had to make some changes to the dsdgen source files from DuckDB so that the data could be generated in parallel in a thread-safe manner. So now coming back to the data generation in Velox with the TPCDS connector, as we saw before, we have the create data source API that is implemented in the TPCDS connector, and it returns a TPCDS data source. So the table scan operator will first call the add split API in TPCDS data source, and it will get a TPCDS split. So what is a TPCDS split? So a TPCDS split essentially describes a chunk of data from the TPCDS table using the starting row and the row count. So once you got a TPCDS split by calling the add split API, you'll call the next API from TPCDS data source, and this will be called by the table scan operator on the split until all the rows from the split are generated. And under the hood, this next API, it uses like different data generation methods that are provided by dsdgen or to generate data for different TPCDS tables at different scale factors. And for convenience, we have defined a wrapper over these different dsdgen data generators so that you can use it with a single API. Okay, yeah, that's it about the TPCDS connector implementation in Presto C++ and Velox. So let's look at the current status. So right now we have a PR out in Velox for the Velox side changes, and this is approved and it should be merged soon. And after that, we'll be working on getting in the Presto C++ side changes for the TPCDS Presto to Velox connector. And we should have full support for the TPCDS connector in Presto C++ soon. And after that, we'll be coming up with a blog post on how to add a connector in Presto C++ in general, and we'll be using the TPCDS connector as an example. So that's all we had. We'd like to thank the Presto teams at IBM and Meta, and special thanks to Aditi, Christian, Deepak, and Jacob from IBM, and Pedro from Meta, and Jacob from Voltron Data for helping with the code reviews. Thank you, and we'll take any questions now.